Okay, we have so far learned how to calculate molarity by figuring out how many moles we have of the solute and how much or how many liters do we want to actually make, or how many parts of a liter we want to actually make. And so we were able to determine the concentration. What I'd like to do now, though, is practice on how you might dilute a stock solution that you have, because you want the same solution, only a different concentration. And the formula is quite easy. All you do is know the molarity of the first solution times the volume that you have of the first solution. That should equal the molarity of the second solution times whatever desired volume you need of that second solution. Okay? So let's look at the first problem. We have a stock solution and its concentration is 1.00 molarity. The solution is sodium chloride. And we want to make 100 milliliters of a 0.750. So we want it a little bit less concentrated than the one. So all you have to do is, what is the desired volume? And you will place 100 milliliters times the desired concentration over the concentration that you have. Oops, that's 1.0. And so there you can cancel your molarity units. You do a little bit of calculating and you come out with 75 milliliters. What does that mean? What have we just figured out? What does that 75 milliliters tell me? I'm going to have 100 milliliters at the end.
Oh, you'll have it'll be the concentration.
No? No, the amount of the total amount of the solution is going to be 100 milliliters. That's what I need to make. It says how many milliliters are needed to make 100 milliliters of 0.75 molarity.
So what is it?
I'm asking you, what does that 75 milliliters indicate? Yes. Yes.
Oh. Did you say it again?
Oh. Say it louder. That was correct.
The amount of 1 mole concentration.
Right. So what it means is the initial concentration is 1.0 molarity. That means 1 mole per liter solution. I'm going to take 75 milliliters of that and dilute it up to 100 milliliters. Now my concentration is 0.75. It's taking 75 milliliters of this concentration and I'm diluting it. I'm making it weaker. So then I'll add 25 milliliters of more water to make it 100. I've diluted it now and the concentration is 0.750 molarity. Does that make sense? Okay. Sometimes in certain reactions you need different concentrations. So let's change this to NaCl to Gatorade. I have 0.00 concentration, molarity of Gatorade. So I want 100 milliliters, but I want it diluted to 0.75. So the original Gatorade solution, I'm taking 75 milliliters of that, adding water to 100, and I've diluted it.
Is that
And now I know the exact concentration, 0.75.
what is the 1.00 F? Is that like grams per what is that?
Moles per liter solution.
That's what it is.
So I have 1 mole of sodium chloride, and I've actually placed it in a liter solution of water. So that's all dissolved. I'm taking 75 milliliters of that out, and I'm making a 100 milliliter solution of it. All right? That's what that means. And oftentimes in chemistry, you have, instead of throwing something away, and you don't want to keep solutions forever, But if you know the next lab is going to use a different concentration, well, you might be able to dilute it and not waste it if you need a different concentration.
So for the next one, would it be 250 milliliters of KCl times?
No. You'll notice here by looking at the equation that this is the molarity and volume of 2. This is the concentration of 1. That's all you need to do to get the volume of the first.
So it would be 100 milliliters times 0.25.
No, no, no. You, see, this 100 milliliter and this 0.1 molarity, that's solution number 2. And this is solution number 1. It's concentration. So you just need to figure out how many milliliters of that you need. So you're going to do the same thing. You're going to multiply these two together, divide by that, and it's going to give you the volume you need. This is you're basically just isolating that variable right there. And you're taking the molarity of the first and just dividing it into the molarity of the second and volume of the second. Simple algebra, I think.
Oh, so we're finding the volume.
Well, in this one you're finding the volume. This one you're finding the volume. This one you're finding the volume. Volume, volume, volume. Because when you dilute something, you have to take part of it and add more water. Right?
Yes.
Okay, so what's the answer for our second one?
0.25.
No. 40.0 milliliters. So.
Oh. I was thinking of the 0.25.
So I would take 40 milliliters of that 0.25 and add 60 milliliters of water to it to get what I need. Does that make sense? Because I want 100. That's what I want. So I'm going to take 40 milliliters of the 0.25 of the potassium chloride and just add 60 milliliters of water, and now the concentration is 0.1. It's weaker.
How would you set that up?
You would set it up as question mark B equals 100 milliliters of the second times the concentration of the second divided by the concentration of the first.
Oh, I got that.
And it gives you 40.
I still have my calculator.
Okay, so I am going to give you the answers to 3, 4, 5, 6, and 7. You work on that. Give you about 15 minutes? No. 10 minutes? Huh? Oh, yeah. The answer to number 3 is number 4 is if you happen to get a different answer, let me know. Whoops. Yep. Because it looks like it needs to be 3 sig figs. And you know what? I have to be honest with you. On most of these problems, I'm not really stickler about the sig fig part.
We just rate 150 ml.
Yeah.
Does that, so would it be easier if I just took my test now?
No. Okay, so see if you can get those done, and we're going on to the next sheet that I have on your table.
What's the next? This one?
Yep. No. The stapled one?